Hello, welcome to day 2 of the summer 2025 database driven web development course. I'm Jim Kaufman with Rankin Technical College. So as far as on the agenda for today, I'm going to review the assignments for week 1. Really, probably more than anything, spend a little time on the lab assignment with you, and the others are kind of self-explanatory. And then besides that, I'm going to go ahead and go through some kind of JavaScript review that'll help with the written test that's also due this week. So I'm going to go through that. A couple other things before we start reviewing the assignments here. I wanted to point out that I just kind of noticed, and it's okay. I know it's early; it's only the second day, but I noticed that a lot of students haven't accepted the classroom assignment for GitHub. So make sure that when you get a chance, because I know a lot of the stuff in the setup here is kind of things you already have, and so I can understand that maybe some people haven't really noticed it, but here's the classroom here, and then you need to come in here and accept this assignment. Okay, you need to accept the assignment, so make sure you do that, and then obviously you need to clone it onto your local machine so you can submit your code, commit your code there. So so please do that. And like I mentioned yesterday, there's also the I'm waiting on this, so it'll be a little bit before that is going to be available to do. So besides that, I think the only really other thing that's probably, obviously the students that had me last semester, we already did some Node stuff, so you already have Node. Probably the only other thing in here besides the cloud stuff, the cloud, the classroom, and then the Tortoise Git if you want to do that. That's optional, but I'm going to go through that later on, not today, but just kind of how to use that. So you have kind of 3 different options, either Tortoise Git, GitHub Desktop, or command line. So, okay. So as far as assignments for this week, let me do this. Let me change this to student view. So you basically, and pretty self-explanatory here. Obviously, everyone's done the written test before, so you got this. It's called exam, but it's basically just a written test, right? It's just called. All these written tests are called exams. And then besides that, so the stuff I'll be going towards the second part of the class today will be, be very relevant for this test here. Okay. And then first I'm going to go ahead and go through this lab 1. This first half of this class, I'll go through the lab 1 a little bit just to get you started. And then here, it's pretty self-explanatory. There's this free code camp role-playing game. It's got 173 steps, which sounds like a lot, I know. But there's this video pretty much will walk you through. You can code along with that. I know it'll take you a little bit of time, but you kind of got all week here, the rest of the week to do that. So I think you should be fine with that. I think that here, let's look at that video. How long was that video? I think it was just a couple hours worth. Yeah, a couple hours, 120 would be 2 hours, a little over about 2 hours and 20 minutes. So you can walk through that, and he goes through all 173 of that role-playing game. So that should help you. Okay, so I'm going to go ahead and go through this lab now. So let's go ahead and go through that. I guess I'll just get rid of that. I'll keep that. So obviously, if you go ahead and get you accept the assignment there on for the GitHub Classroom, you'll already have a labs folder, but just in case, create one if you don't already have it. But if you get it, you'll have it. And then you're just going to need to create a subfolder under that. So, I know like some of the other courses kind of had all the folders set up, but, really not, you can do that yourself. Kind of good practice anyhow, because in the real world, you'll be doing that as well at times. So, create a new folder, which y'all have done before. So create a new folder for this lab, this Lab1 and I just added this. Not sure if anybody's looked at this lab assignment yet. I just added this. Was it yesterday or today? I think it was this morning. I added this morning. This lab requires Node. So if you don't have Node, please download and install it. Let's go there real quick. So just so you can see. So basically, down here, download node.js. Okay, just follow along on what it asks you to do there. You just go ahead and install that. And after you install that, you should be able to go to your let me clear this. And for, the students have maybe not done this yet, whenever you're in here, let me make this a little bigger. You can go up here to terminal, new terminal, right? You might not be used to doing this. Obviously, some of the students who were in earlier HTML courses, the earlier web technologies courses, not sure if you did any Node stuff. We did towards the end of the web technologies course last semester. We did a little bit of Node and React stuff just to kind of get a little familiarity with it. But I'm not sure that there's maybe up to 3 different students that, haven't had the web technologies course for almost probably a year and a half. So, and I'm not sure if you even did any Node stuff. So you may have to download Node. I'm kind of assuming that you haven't done anything with Node yet, so you need to download that. And then you come in here basically and go ahead and go to new terminal. And here you can go ahead and type in Node-V. And this will tell you the version of Node. Mine's a little older. I need to update mine. So if it's installed correctly, you'll see a version number there, right? If not, please let me know, and I can walk through that with you if you have any problems having Node installed. Okay. All right. So I want to go through a few things here on this. Let me see. Step 4, I guess is step 5 now. Since I don't know why it says that like that. Let me just even get rid of that. I just call it step 5 maybe because I added one up there. All right, sorry. All right. So here it's just telling you go ahead and create a index.mjs file in your root directory. Now let's just go ahead and do that real quick here. I wasn't going to go through this, but for somebody who hasn't already done this, so we're just going to do index.mjs. And in here, let's go back to our code real quick, or go back to our lab assignment. What are we doing in here? Okay. So we're just going to go ahead and put this hello world like this. And then we're just going to run that, and that's it. And then in here, you just go ahead and do node. And then the name of your file. And when you're doing this in the terminal here, you just kind of get started. Depends on how many files you have, but you know it will go ahead and complete it if, like, you know, here it's kind of like that's the HTML file because I already have one. We don't want that one. You can just hit the tab again, and then it's MJS, and then hit the enter key, and it'll execute that. So, and it'll go ahead and it's spitting out hello world, so you know it's working, right? So that's just kind of in the lab is showing you this is, you know, basically just a basic file, how you use Node to run a file. You know, you're running, you know, we're going to go into Node a lot more next week, but, you know, Node's basically an environment. Instead of you running this within a web browser, you're running it within the Node environment is what you're doing, right? And you use command line to go ahead and execute JavaScript files in the Node environment. Okay. Okay, just want to go through these best practices real quick. I know Mr. Gubinstead's kind of set these up, said this a little while back ago. I'm on board with what he has here as well. There was somewhere something was mentioned in some file, some document I ran across at some point where it talked about how many, you know, setting up spacing, and I think he had 2 in there. I'm fine with, you know, as far as spacing, as far as, you know, you want to kind of really make sure that you're consistent how you in your like JavaScript files, your spacing, your tabbing, so to speak, and you know, he had like 2 spaces, and I know some maybe places that's kind of a standard, but I've always, from my perspective, always used 4, and most people I know have also used 4, and I think all in all, as far as 4 spaces for indentation, right? Indentation for in your JavaScript file, I think 4 is, you know, probably a little more widely used, but you know, you can use 2 or 4. Just be consistent. Don't be using 2 here, you know, somewhere in your file and using 4 spaces for indentation somewhere else. You know, just make sure you're consistent on that. But don't use var. There's no reason to use vars. That's kind of old school, and there's some, and we're going to talk about that a little bit later today on, you know, there's some limitations with that. There's some problems with using var, so you really should always use const or let. And basically for a const, as long as if you're going to define, you know, always try to use const if you can. If you set some, if you have a variable you're gonna set to something, and then you're never going to change it, you can always use a const, right? You can always use a const set, you know, to set a variable to anything, as long as you're not going to change it, right? And did want to mention though, I know we went over this in the HTML, you know, the web technologies course, and we'll talk about it again here going forward. But with a const, even if you have like a object, and when you're using an object, you're actually pointing to a reference in memory as opposed to like a primitive in that. And if you use an object, you can actually change. You can change something in that object, and it doesn't kind of go against the whole idea of changing anything with a const. Right? It can actually change something within that object. You can't just change what that const points to. Okay, and I don't want to confuse you on that. We'll go back. We'll get into that in more depth later on. But for most part, like primitives and stuff like that, or you know, are objects that if you're just going to set it to something and you're not going to change anything, you know, always use a const, right? If you know that you're going to have to change the value of something, use a let, right? Try in most cases. You don't always have to, but you know, try to use arrow functions. prefer arrow functions for anonymous functions over traditional function declarations. So try to get in the habit more of doing it this way. It's kind of more modern, and there's some benefits, other benefits as well in that. The functional declaration syntax is permitted for creating name functions. Function add like this, and then you return something. Template strings. So, this template strings were something that was, really fantastic when that came along, because before, and, I've wrote lots and lots of code and seen lots and lots of other code from others where instead of before template strings, you had to actually do a concatenation where you had to use a plus sign. So you'd have one thing in quotes and then a plus sign and something else in quotes. And, with the template strings, you just put it all in those backticks and you're good to go. And you can drop variables in there and everything else like that. Very, very useful. So try to use template strings instead of using string concatenation, using like a plus sign. Use number to fix to format your numbers for display. If you want to pad numbers, put padding in between your numbers. Okay. You can use the pad start. And we're going to be going through a few of these things here. We're going to see a few more of these things here today, but I'm just going to going through this now since it's part of this lab assignment here. As far as arrays, use array push to add elements to an array. Use array find to search for an element within an array. And what else here? If you need the index of an item, you can use array.findIndex. Okay. All right. So this first exercise is miles per gallon calculator. So now, since you've already to do this lab, do these labs, or these exercises within lab, there's 4 exercises within this lab, you're going to have Node installed, right? But we're not going to be doing a lot of, things that are that much newer. Well, I shouldn't say that. Like the readline module, we're going to be using this readline module, right? We're going to run this thing command line. So that's going to be new. I'll show you some other things that are also going to be new just for this, but we're not going to be doing a lot of things related to Node and modules, but I'll show you what we are going to be doing just to get through these exercises. Like I said, next week we'll get into Node, a lot more in depth. So let's go ahead and take a look at an MPG miles per gallon calculator here. And we're going to kind of go through a lot of that here. Let me see here. I want to also bring up something else. All right. All right, we're done with that one. Let's go to our miles per gallon here. We can make this smaller. Okay, so what you're going to see in here, it's a little different. Obviously, we're using the MJS extension, which is a module extension, right, as opposed to just a JS file. So we're using the MJS extension, okay? So that's kind of something different than just what we normally have done with JavaScript. A couple other things you're going to notice, we've got some import statements, right? So this is something that's a little different, right? And these are what's called, these are built-in modules that's available within Node, okay? Now, even though we always talk about, always remember that Node's a JavaScript environment, right? It's not a programming language of that, but it does have some built-in modules that can be used. But you're still using JavaScript, right? But it has some built-in modules that you can use. And in this case, we're using this readline because this was part of the requirement for the lab. And then we're using this node process, so we can do a input and output type thing. Okay. So first, let's go ahead and look at read line. And if we go back to our exercise here, it tells us, use this read line module. And so let's go ahead and go to this. Actually, I think I have it already up here. So if you come into this page, if you click that link, come into this page, you're going to see that there's kind of some different options here. So if you see something with require, this is kind of the older way to do this. All right. Whenever you see require, that's the older way. The newer way is that's using the common JavaScript. That's the common JavaScript module. The newer kind ones is ESM is the newer way to do it. So we're going to go ahead and do that. So if you go over here and click this, it'll change. And as you can see, this is exactly what I already have in mind, right? I have this import, right? So import read line. Okay. So this this also shows you, and here, how my code was, I have these two here just like this, right? So this is kind of giving you a lot of what you need to even start this. But obviously, I'm going to be going through this so you can just, code along or, what I'm going through here. Because I'm going to kind of pretty much go through that miles per gallon one for you. And then the other ones you're kind of do yourself. But the fourth exercise, I'm just going to kind of show you a little bit on that as well. So these are the parts that are very important. Well, all of this is. That we're going to be using here. So let me get back to the code here. But like I said, this is the old way is using the common JS with the require, and the import is the newer way to do it. So always remember that the new way is always going to be import. The old way is going to have the read line or the require. All right. So, like I mentioned, three different things now. That's a little different than just normal JavaScript. We've got these imports. Then we also call this file MJS, which is a module. And then also the fourth thing is this create interface. Okay. And a few other things I'm going to point out that's a little different. We're using this async, await, and we're using that. We're saying this is an asynchronous function, and inside this asynchronous function, we're using an await, and I'll talk about that a little more here. And then also, we also have this await here as well. Okay, so we have two awaits. Okay, and I'll show you what that means and how that works. So let's go and. First, that on our read line here, it says promises. So what is a promise? A JavaScript promise is an object representing the eventual completion or failure of an asynchronous operation and its resulting value. It allows you to handle asynchronous results in a more organized way than the traditional callbacks. Traditional callbacks is how it used to be, but that code was always very messy, and promises makes things a lot easier to handle. So obviously you want to try to use promises instead of using callbacks. If you search, play around, looking some examples on the internet and that, you'll find a lot of code that has callbacks. But for the most part, you really should try to use promises. Okay, it's going to make things a lot cleaner, and it's a lot better for error handling and understanding. Okay. So we talked about the word asynchronous. So an asynchronous operation, there's two different ways. Something could either be synchronous or asynchronous. Okay. Synchronous basically means you call something and you wait. You call and nothing happens in that main thread We haven't talked about threads a lot. I'll go into that more next week. But there's usually a main thread that's running, and sometimes there's other threads are running in a program. Okay, a program isn't always necessarily one thread. Okay, but there's a main thread that's running, and when you're using asynchronous, that main thread is making a call to something, and it's waiting. It's waiting till that gets done until something else can use that main thread. Okay. For asynchronous, that's different, okay? Asynchronous operations are tasks that are initiated now. They're initiated, but they complete at a later time without blocking the main thread execution, right? So you'll have a main, you'll start it, and then the main thread can go ahead and do other things while the asynchronous thread is waiting for some task to complete, okay? This allows a program to continue running other code while waiting for an asynchronous task like fetching data or reading a file to finish, okay? And so that's what's happening here. It's hard to kind of show that, and especially in this kind of an example, but we'll look at examples in the future where you can kind of understand, to help you understand that a little better. But in this case, this is kind of a little more basic, and I don't want to confuse, make things more confusing than they need to be here. Okay. And the other things that we're also talking about, there's an async and an await. Okay. And so what this is, and they call this synaptic sugar. And it's built on promises. It's all about it's built on promises. It provides a more readable way to write asynchronous code that looks and behaves like synchronous code. And it's more for readability than anything, okay? The asynchronous keyword is used to declare an asynchronous function. So by doing this, you're saying, hey, this is an asynchronous function, okay? Which implicitly returns a promise. So this is going to return a promise. Let's see here. Well, it returns a promise while the await keyword can only be used inside an async function to pause its execution. So what this does, and I know this is a little bit confusing, and in time you'll understand it a lot better, but this await is actually going to pause the execution. But when I was saying earlier that asynchronous, what it does, it goes ahead and executes something, then it's going to pass, then the main thread can go ahead and do other things, right? But that is still the case here, okay? Even though this await is waiting for this to complete, it's still in under the hood, so to speak, already passed. Once this is executed, right? Once this is executed, this await's going to wait for this to finish. It's going to wait for this to finish, but at this point it has already passed. It already passed it to the main thread, so the main thread can go ahead and continue to do something, okay, until this gets finished. So the main thread's doing other things it needs to do, okay? But this specific thing is going to wait until this is completed before, okay? So let's just kind of run this real quick just to see this in action. So I'm going to run node, and we're going to do this MP. What happened there? I hate when it happens sometimes. Let me clear that here. All right. Give a little more room here. All right. So I'm going to do a node. And I'm going to do MPG. Just do start at MPG and hit tab, hit enter. And we do enter miles driven. So what happens is this is executed, but this doesn't have a value right now. This doesn't have a value yet. It's waiting for input, and that's what this is. This RL. This RL is read line, right here. It has input and an output, right? So the input is this right here, and the output is going into this, right? So here, I'm going to enter miles driven. So let's say I'm going to say 200 miles. I'm going to enter. How many gallons of gas? So what happened there is this waited until this completed, until this input completed. It set this. Then it went down here. It went down here. It executed all of it went down here. And went ahead and executed this one. And now we're waiting for enter gallons used, right? So I'm going to go ahead and just do 20 gallons, hit enter. So our average miles per gallon is 10. So to go back up here, whenever you use a while loop like this, always remember is you have to make sure that you can get out of this while loop, okay? And to get out of, especially when you do it like this and say while true, if the only way is how we're getting out of this is we're doing a break here. If you miss this break, this will be an infinite loop, and it's just going to keep on running and running and running and running until memory becomes a problem, and your application can crash eventually. It will crash eventually, because you'll get in. This will create an endless loop. So you always have to make sure you break out of it. Whenever you write code lists, you have to give it a way to break out of it, and that's what it's doing here, right? So you got two while loops, one of them for the miles input and the other one's for the gallons input, right? What else do I want to point out here? Another thing that's very important is whenever you're using these read lines, when you ever create this like this, you need to close this. So you always need to make sure that you close this at the end, okay? And actually, this would be a good place actually to do some kind of a try, catch, finally thing, where if some error happens, then you can ensure that you have, in fact, closed it. It probably is going to be fine on its own. I'd actually have to look at the documentation on this to see if it's all right anyway. But obviously, it's whatever you're closing, kind of like an input stream when you're closing things like that. It's always kind of good to put that in kind of a finally thing. That's a cleanup kind of task where you have some kind of a try catch, and then part of your finally is to clean things up where you close things like that, right? Let's go ahead and go through this in a little more detail. Let me go up here. I don't want to. So like, what does each line do? So import star as read line from this, this is a node module, right? This line imports the read line module from the Node.js using the ES module import syntax, right? Whenever you use the import statement, this is going to be using the ES module import syntax as opposed to the common one. So the import star as read line, this imports all exported members from here. So it basically imports into this variable the export from here. This exports into this, okay? So it's going to import star into read line from everything that comes from here, okay? And it's bundling everything in here into this read line, right? Because you could have it just like here. We have promises. There's also this one that's available too. We're using promises, but you could also do that. And this would, import less stuff, right? It's going to import different things, right? So you're setting this as kind of as a variable, so to speak, right? So, so this specifies the module to import. The node prefix is the modern way to indicate that you are importing a built-in Node.js core module. Version that provides promised. Okay. Kind of the same thing here. This is a node process, and this is another node module, and this uses what's called object destruction and renaming in the import by by doing the standard in, standard out, and then setting them the standard in as a name input. So you could call this whatever you want, right? This is your own idea, but you're going to have to change it in different places. So that's it. All right. Yeah, I don't want to go through, bore you with too much of this. But the important things here, just kind of understand a little bit, understand about, by doing this async at the beginning, you're making this an asynchronous function. You use await to pause execution until something's returned. In this case, we're pausing it until we're entering something, right? Entering something at the command line. Also, make sure whenever you're using a while statement, when you do it this way with a true, this is always going to be true. This never is false. Don't change to false. The only way to get out of here is to break out of it. I guess that's about it. So you can basically look at this code. Pretty basic. We've done things like this already in the other courses. I think we kind of do this miles per gallon at every course at some point. So, but here's the code for that. Pretty straightforward, I think, for the most part. Just getting beyond some things that you may not be used to as far as using Node. All right. So you guys have any questions about anything on this? All right. So that was a miles per gallon one. And then so for the temperature converter, I'm not going to go through that, but for the most part, a lot of what we did with the read line and everything else, you're going to pretty much do the same thing that you did for the miles per gallon. Right? You're just going to go ahead and do a conversion for Celsius or Fahrenheit. Okay. The only thing there is you're going to have to do something where you're going to have to ask the question, which one do you want to do? Do you want to do a Celsius or do you want to do a Fahrenheit? Right? So that will be, that's going to be what's a little different there with the miles per gallon, is you're going to have to do a separate read line. A separate read line. And here, let me see if I can show you something on that. Okay, so, here's a possible option. Way to do this. Let me clear the screen here. I'm not going to give you all the code for this, but you basically, you're going to want to ask, a question. Here's just going to display the different possibilities here. Celsius to Fahrenheit, Fahrenheit to Celsius or exit, right? And so enter your choice, 1, 2, or 3. If choice is 3, then you're just going to exit out. If it's not, it's 1 or 2, then you're going to go ahead. Oh, this is testing. Ask again if you put the wrong one in. If it's a valid temperature. So let's just go ahead and run this. So basically this is just asking you to enter a choice. So Celsius to Fahrenheit, Fahrenheit to Celsius, or exit. So I'm going to do number 2 here and put in a value of 90. And then this is just going to be a continuous loop until you exit out of here. I don't think it really says you have to create it that way. Let me look at that one more time just to make sure. Accepts the temperature, you can just do it one time. It don't have to be in a loop that you can constantly add that, constantly do it, but you can just do it one time where you give them you don't have to put that part in a while loop, but this example is in a while loop. Let's just test this one more time. So enter temperature value. So 40 degrees Celsius is equal to 104 degrees Fahrenheit. So basically, a different option, right? You have to first do that before you. So first you have to find out, and it's kind of similar, I guess, because for the miles per gallon, you still had to enter one then the other, right? So here you're kind of doing the same thing, but you're just saving things, and you're going to make a decision based on your choice. Do you want to do the Fahrenheit or do you want to do the Celsius, right? So then you just hold on to that, and then you ask the next question is to have them enter a temperature. So not too difficult, not too much more difficult. Okay. Now for this income tax one, the important thing I really want to point out on this one, I'm going to let you do this on your own, but just remember, sometimes students make the mistake where, sometimes students make a mistake where they'll tax everything from 0 to say 48,745, all of it at 12%. You just have to remember that for tax tables, up to from 0 to 11,925 is going to be 10%. From 11,926 to 48,475 is going to be 12%. So you'll have to take this amount, you have to take the tax on that amount, and then add. So basically, add that to this amount, right? So you add it together, right? That's probably the only thing. I just know that, I've seen some students make that mistake for some reason. I think that was before there was kind of a link there that just told them to do it. And they were so they take all the income and multiply by 12% or 22%. But you have to, you have to do it based on, the high values here, okay? All right. And then we have this multiplication table. I'm not going to show you everything on that, but I do want to show you, because that could be, I'm going to give you quite a bit on that though. Let me see here. So you go ahead and do the things you did with the read line and stuff like that. You're going to do the same thing for this. For the multiplication table, you're just going to enter, between a 1 or 12 or whatever it is. So I just kind of want to help you through this. Some people can kind of get confused with this. So if you want to go ahead and use this, that's fine. I'm kind of giving you a lot here on that. Just because I know you can look at that table and say, oh, how in the heck do I get that to display? So here's kind of here's an option for you to go ahead and print those table rows. So here you go. So you can go ahead and take that for that one. And then obviously you're going to have to do the other parts of it with just reading it in. But this will create the table rows for you. The important thing here is using this pad. This pad start. Pad start puts that padding there. So if I run this, let me get out of this one here. So here, let's see, let me get a little row. And so there you go. And that pad start, puts all this padding in here between these numbers, and that makes it nice like that, right? So basically that block of code is going to actually create that. So I did a lot of that for you. So just because I know it's might be a little bit of a struggle here at the beginning. So that's that. All right, let me see what else is in there. Well, I guess that's it on that. Okay, I'm going to go through some JavaScript theory that's relevant for the written test. So, in modern JavaScript, later versions of JavaScript, const and let are preferred over the var keyword, using the var. Constants used for variables whose values should not be reassigned after initialization. It's best to practice to use const by default because it helps prevent accidental reassignments, making your code more predictable and easier to reason about. Now, one thing I would do as far as, I look at there being kind of two different kinds of const. One is where it's kind of what I would say a true constant. So like, pi, right? Or, setting it to some specific type thing that you say, oh, yeah, I know that's always going to be a constant throughout the thing, throughout this program, as opposed to something that, something that's generated, even though that it's still okay to use a const for something that's generated, or it could be, something that you don't know it's going to be, but I would use for a true constant, say like for pi or something, that's where I would use like the uppercase, or if it's something like, first name and being, I'm always going to be using my own first name, Jim, all the way through this program. So I set first name to Jim. I'd make that all uppercase with with an underscore in between first name, first and name or whatever. But if it's more than one syllable, so to speak, then you use an underscore. But if you can always put it all together, but I would use all uppercase in cases where this is a kind of what I would say a true constant, as opposed to some other variable that may be assigned to something differently. I hope that makes sense. But besides that, then you go ahead and just use camel case for any other kind of constant. So like in this case, it's showing this would create an error if you do something like that. Let's just go ahead and look. I know that we've kind of done this already before, but okay, so here, this one, we'll go ahead and so obviously you try to change the value of this. This is a const. We know we're going to get this type error assignment to constant variable, right? It's not allowed, so we can't do that. Let obviously is used for variables that may need to be reassigned later in the code. So here's a let to initial value, try to change it to a new value. This is allowed with a let. var is the old way to declare variables. It has function scope or global scope. So it's going to have scope within your function, if you define it within your function, or if you define it outside your function, it's going to have global scope. And it can lead to unexpected behavior due to hoisting and a lack of block scope. Whereas let's going to have block scope, right? So, but it's going to lead. It could lead to unexpected behavior due to hoisting. Now, hoisting, if you can remember that, is the fact that in JavaScript, the concept of hoisting, it kind of moves it up to the top, so to speak. And the whole idea of moving it to the top, obviously, it's not moving it physically in your file to the top, but in memory, right? Always remember hoisting, it's going to move that to the top, okay? Let's see, template strings. So in JavaScript, how would you write the following code using a template? Okay, so just remember that for template strings, you're always using the tick and you're using the back tick, not a single quote, right? And when you do that, you can obviously, you can obviously put variables in there as well, which is really nice. Okay. And then another thing about single ticks, you also could do multiple line stuff like this. So let's see what we got over here. Hello, Jeremiah. Can't see that's on one line there. That's on one line. The first one, the second one's on 3 separate lines, because this will actually, it's kind of automatically get new line characters in here because of putting it on a new line. We'll put it on a new line, and that's only going to be the case for if you use a tick, right? If you try to change this to something like a quote here. Right, this is just gonna be an error. It's not gonna do it because of being on this different lines here. You're gonna have a problem with that, right? That doesn't work. Okay, but by using the backtick, the template string backtick, then you can put things on multiple lines, and it will reflect on multiple lines. Okay, arrays. So we'll look at the push method, adds 1 or more elements to the end of an array. So remember, push always ends to the end of the array. So here we've got dogs equals buddy and lady, and then we got a new dog called Max. We push the new dog, and now we're going to have buddy, lady, and Max, and that's on line 50. And we have, as you can see over here on the right-hand side, buddy, lady, and Max. For some reason, I guess just how this works within the browser. It's kind of holding on to these other ones, so it's kind of interesting. Well, I guess I just say it executed all this. It kind of executed all this, and so in this case, it's at this point in time, what this does, the reason this is like this, let me reiterate, the reason that this is like this is because this console went ahead and when this executed, this console would display this execution at this point in time, okay? But when you click on this, just this tool within the console, it's going to give you the value of that array. It's giving you the value of this dog's array, but it's giving you the value of that after this has been already executed. Because in this example, everything's already executed, right? So that's why you'll see that here like this. Because this is the current value right now of this array is this like this. And then what we've got printed out here was just the value of this array at this point in time. Just to point that out. Okay, and then pop removes the last element for the from the array. So here's 53. So it just popped off Max. Popped off Max there. Other methods to add elements include unshift, adds to the beginning, okay, and splice. Can add or remove elements at any position. Okay, so remember that unshift is always always adds at the beginning. So here we're doing unshifted Charlie, and this was on line 58. We printed on 59. So it went ahead and at the first position, it just moves the others over. So that you got Charlie and then Buddy and then Lady. Here's an example of splice. And you're just basically saying at your, starting at, the 0 index, adds Bella at index 1 without removing any elements. Okay. If you had this, let's save that. And this is what, on line 62, or will be 63 over here. Charlie, Bella, Buddy, Lad. So it is different there, right? Yeah. So it removed the 1, right? So if you have a 0, it's not going to remove it. Okay, we're doing that. This is splice here, another splice. Yeah, well, yeah, it's removes 1 element at index 1. Okay. Oh, yeah, you're just doing that without, this also adds it without removing any elements. This just says, let's remove 1 element at index 1. So in this case, line 67, 68, Charlie, Buddy, Lad. Yes. Correct. And here's a find method for searching. Here's an array of pets named Buddy, Lucy, Lady, and then your finding Lady, and then here's your output for this one, 82, and it's just kicking out your output of that specific one. So this way you basically have a, 2 properties, both name and type. So it's going to print this whole thing, right? Let's see here. So if no element satisfies the testing function find, returns undefined. Other search methods include filter, returns a new array with all elements that pass the test. Okay. Includes, check if an array contains a specific value, and you can use index of, returns the first index of the value. So always remember, if you've got have an array with multiple identical items in that array. If you have identical items in that array, you do an index of, it's only going to return the index of that first one. It's not going to return the others. Just a little background on JavaScript. JavaScript was created back in 1995 from Brendan Eich, who worked at Netscape Communications. And so Netscape was one of the very first browsers. It's before Chrome days, before Internet Explorer, Edge, and there's plenty of other browsers nowadays, Opera and so forth. But that was one of the first ones, and he created it really quick, like in a few days or something, right? So it was something that just quick. They created it very early on, very quickly, and then it's kind of expanded from there. It's one of the most popular languages. If you go look at all the most popular programming languages, which it's considered a scripting language, right, as opposed to other kind of language, a dynamic language, right, as opposed to a compiled language, a static language like C# and Java are static languages. JavaScript's a dynamic language, right? And then that name, initially it was called LiveScript at the beginning, and then they ended up renaming it to JavaScript. And the reason for that renaming to JavaScript was so that Java was a programming language that was very popular back then, and so they were kind of piggybacking on the success of Java, so they called it JavaScript. So sometimes that causes some confusion. I remember early in my career, kind of having explain to people because they get confused about Java and JavaScript, and that thought that there's something they're the same or what, and no, it's actually two different languages, right? Just used the kind of the same naming on that. So what is ECMA script? Is a scripting language. It's a specification. It's often abbreviated ES, is a standard developed by the ECMA International, specifically by a technical committee. It's official specification upon which JavaScript is based. So JavaScript is the most popular implementation of the ECMA script standard. So early on, there's too many companies doing their own thing. And so really when they started really, developing these specifications and these standards, it kind of really helped out everyone. So before you could use JavaScript was different in one as the other, and you had to do all kinds of little special testing for things, and if it's internet, it used to be a big for Internet Explorer. If in Internet Explorer, do this. If not, do that. You had to do all kinds of little different things, which nowadays has kind of pretty much disappeared, which is great. Makes things a lot easier. Then browser vendors do these features, yeah. And it helped with obviously the creating of a Node.js when you've got a standards in place. It's a lot easier to create something on top of something else when you've got standards and specifications in place. Okay, let's see. Is this the same thing? Globally scoped. Let me see. I guess not necessarily. Variables declared with var are function scoped or globally scoped. Okay. We already talked about that. This means their scope is limited to the function they are declared within, or if they're declared outside the function, they are global. They are not limited to the nearest block, like an if statement or a for loop. This can lead to issues like variables leaking out of blocks. So this is an example here. So let's go down to 120, 123. I'm a var. So yeah, so here's this block, right? So here's this block, and then you've got, here's this block where you define this variable, but outside of this block, you still have access to this variable, right? So you can see sometimes that you could have some things like, and this is especially like sometimes you import libraries and everything, and sometimes if a library is using the same variable name as you're using, and you've created something like this, you made this by doing this, you made this global, without thinking about, you would look at that and say, okay, I'm in this if statement, I created this variable, and once I'm out of this if statement, this variable's not needed, not used anymore, right? Well, yes, it's still pointing to that variable, right? So it's outside, it's accessible outside that block. In contrast, let and const are block scoped, right? So I'm going to go ahead, I'll just uncomment these out. So this is, obviously, you're going to have your reference there because you're trying to access that, and it's not defined, right? And I should just move on to the next error. Yes. So, all right. So if there's any reason, sometimes you kind of can get confused about, well, what's the big deal about var and that, this is, a very specific situation where you can really see that, hey, you can understand that You know, sometimes you could define a variable somewhere and think, okay, well, I'm just using this variable here. But then actually it's accessible somewhere outside of that. So, you know, by you defining that variable within that block, it's actually now globally scoped. And like I said, sometimes when you're, you know, very complex, you know, stuff we do for this course, you know, it's pretty limited, but, you know, we are starting to use modules and stuff like that. So, you know, anything's possible, right? And sometimes there's other libraries you could be using as well, some third-party libraries where you bring in that library. Well, you may be using some things within that library, and you know, you don't realize that there's a variable that's the same as something that you've created, something like that. You know, there's ways to actually prevent that and to, you know, namespace wise, but you know, it just kind of increases the chances of something going wrong, so to speak. So, all right. So let inside. What happens if you declare a variable with let inside a block? The variable is confined to that block. Yes. So always remember, a block is typically defined by curly braces. Yeah. Variables declared with let inside a block are only accessible within that block. So they're block scoped. So, you know, always remember block scoped. Vars are not block scope. They're function or global. And let are block scoped. All right. So what's this? Yeah. Block scoped, function scope. Okay, well, we kind of are already looking at that. So you're outside this block, so you're not going to have access to that. This is function scope. So you create it up here. So anything within a function, anytime you're within this function, you create this variable with this let up here. You're within this function, you're going to have access to that, right? That's understandable. Just shows here you got a block scoped. Since it's within this block, you defined it in this block, it's not going to, even though it's within the function, it's not going to be accessible. All right. So real quick, just go over data types. Probably been a while for primitives. So you've got different types here. You've got a string, number, Boolean, null, undefined, symbol, and big int, right? Them are the different, big int probably won't use a lot. You won't even use symbol a lot. Depends on what you're kind of doing. I haven't. You know, I do remember some code a while back, you know, some years ago that we're using a lot of JavaScript symbols, but all in all, I haven't seen a lot. But maybe it's just maybe the stuff that I've worked on and that you know, that was just the case. But symbol, I don't think you used, you know, it's unique. It's immutable primitive value, often used as object property keys. And, you know, maybe it's just because it was kind of introduced. Probably a lot of the stuff that I was doing was probably earlier in that. So maybe it is used a lot more than I realized. Big ints for just, you know, really big integers. You know, you got to be doing something pretty significant for wanting to use a big int. But these are primitive types. Just, you know, good idea to really just, you know, have these memorized. At least, you know, string, number, Boolean, null, undefined, symbol, big int. Them are the Boolean, them are the different primitive types, right? And kind of really realize too that primitives are stored in a different place in memory. You know, I'll bring this up later on. I don't want to get too far involved in this. You know, and I know I've brought this up in the web technology course that, you know, primitives or, you know, variables and primitives are stored differently than how objects are stored in memory. And we'll talk about that again. You know, it's a good thing to kind of understand at least a little bit. If you ever go to an interview and, you know, it's kind of some good stuff to be able to throw out there. If you know, obviously if they ask it, maybe you can weave it in yourself just by throwing it out there. That's always good to do too. If you can kind of control the interview a little bit and talk about stuff you want to talk about, you can get away with that. Sometimes that's really good. So we can talk about taking control of interviews later. So everything in JavaScript is an object. Arrays are a type of object. Functions are also objects. So there's this idea that functions are first-class citizens, right? In JavaScript, how are functions treated? They're treated as first-class citizens, and what does that mean? Functions are treated as first-class or first-class objects. This means that functions can be assigned to variables, passed as arguments to other functions, returned as values from other functions, or stored in data structures like arrays or objects. This characteristic is fundamental to functional programming paradigms in JavaScript. Okay, so just remember that JavaScript functions are treated as first-class citizens. Means you can do all these different things. Assigned to a variable, you can pass a function as an argument. It can be returned as values from other functions. A function can return another function, which is called high-order functions. And it's also can be stored in data structures. So it's probably a good idea to understand when to use different loops. And so for a for-in loop, iterates over innumerable properties of an object. It will include properties from the object's prototype chain. And don't worry if you don't understand quite what that means, because JavaScript uses prototype, a little different than other programming languages that kind of they're class-based, like C# and that are class-based. C#, Java, they're class-based. JavaScript's a little different, even though they have some object-oriented type concepts. They're not true. You can write classes in JavaScript, but they're not true classes. It's just done a little different in JavaScript. It's called prototypes. Okay. So it will include properties from the object's prototype chain as well, which sometimes requires checking if a property belongs directly to the object using has own property. So you can use this has own property thing. And so if you're ever asked, about different loops, a for-in loop can iterate over the properties of an object. Let's look at the advantages. Oh, here, let's not skip this one. For iterating over array elements, for loops, for of loops, for each map are generally preferred. Okay, so you really don't want to you don't want to use really a for-in over an array. So that's probably the easiest way to remember that. You don't want to use a for-in really for arrays. Okay, not to say you can't, but you really shouldn't. The other options are better. Advantage of ES modules. What is the main advantage of ES modules in JavaScript? They help organize and reuse code using different files. ES modules using import and export keywords provide a standard way to modularize JavaScript code. So that's what we're using, right? We're using the imports, right? We use imports. And we haven't done an export here really, but we have seen, the people who are from the previous web technologies course last semester, we did a little React stuff, so we did some exports, right? So there's some imports and exports, right? ES modules. Advantages include code organization, breaking down large applications into smaller, manageable files. Reusability, easily sharing function variables or classes between different modules. Dependency management, clearly defining which parts of your code depend on others. Better performance, browsers and build tools can optimize loading modules. Avoiding global scope pollution, variables and functions declared within a module are local to that module by default, preventing name conflicts in a global scope. Okay. Require separate files conceptually. Yeah. Yeah, well, it's just showing here you've got, you've got some functions by the same name. You might be calling multiple things in. And, that's kind of what I was mentioning earlier. Preventing naming conflicts, especially like when you're calling in multiple things, okay? So modules help with that, okay? Modules will help with that. Falsy values. Which of the following values are considered falsy? So in JavaScript, a falsy value is a value that is considered falsy when encountered in a Boolean context. Like in an if statement condition, the falsy values are obviously the Boolean literal false is always false. A 0, the number 0 is false. A negative number 0 is false. A empty string, right? Not a space. If you have a space here, this is going to be true. Just having a space will make that true. An empty string, that'll also be falsy. Null, undefined, and not a number. So all of those are considered falsy values. So that's one of the things, really different about JavaScript as opposed to other, programming languages. There's really not so much of the idea of falsy in that. There's in JavaScript, there's a lot of things that can be considered falsy. So you can put those in if statements. If you make some call, if that returns, if anything you put in if statement, if it returns a false, it's going to be false. If it returns a 0, if it returns an empty string, if it returns a null, an undefined, or not a number, if you're making from your if statement, you're making a call to another function and bringing it back, then anything that returns any of these are going to be false, right? All other values are considered truthy. In this case, it's hello. Obviously, that's truthy. Here, you're asking if it's 0. This block will not execute because 0 is falsy. Function definitions. Here are common and valid ways to define functions in modern JavaScript. You basically have a function declaration. This is the more traditional way, right? Here is a function expression where you've got a variable, right? And you're setting that to a function. Here you're doing an arrow function. It's a type of function expression introduced in ES6, right? Basically, they're all kind of doing the same thing here. They're just printing out a log statement. So obviously, this is the most condensed one, right? Most condensed one. Oh, yeah. Function equals my function. Yeah, okay. Oh. I think that's like a question in the thing there. Yeah, which operators used to check for both values and a type of equality. So remember about the triple equals is strict equality operator. So as you remember that, JavaScript will try to convert both operands to a common type if it can, right? So if you use a double equals, it will It will try to convert both operands to a common type, and then test if they're equal. If you use the double equal, if you use the triple equal, it's going to prevent that, and it's not going to try to convert them to a common type. All right. Yeah. So here, like null equals undefined, that's true, right? So here, where's 310? Let's go 310 here. So that's true. So that's because, you kind of look at that, you wouldn't think that that would be right, but it is, because this is falsy and this is falsy, right? Does false equal false? Yeah, it does, right? Falsy equals falsy. Put another equal sign in here and hit save. 310 was true because falsy equals falsy. Now it's going to be false, and that's because you use the triple equal sign, right? Here, it's just going to, if they're both falsy, it's going to say true. Let's see, 310 true. So there's that. Okay. So basically, you truly want to, in most cases, you really want to try to use the strict equality operator, okay? Just to make sure that you don't, if you really get in a habit of that, you can do something you don't realize you're doing, right? Something like this, how easy could that be, Or, maybe something, obviously you wouldn't do it quite like this, but you might call a function that, is returning something here, because, you call a function right inside here, and call a function right inside, on this part and this part. You could be calling two different functions here. You don't know what it's returning. And if one returned null and one returned undefined, in this case, this would return true, right? So it's always best to really use the triple equals, that strict equality operator. So all arrow functions are anonymous functions. That's true. Arrow functions are a concise way to write function expressions. They are indeed anonymous, meaning they do not have a name bound to them in the same way that function declarations do. When you assign an arrow function to a variable, the variable name is used to refer to the function, but the function itself is anonymous. All right, the name of the function declaration available within the function scope. All right. I guess I got done earlier than I thought I would today. So I guess that's all I have. So what we just went over here should help you with the written test. I'll mark this in the video so people can get to this easier. And I'll send an email on where the different parts within this video on where the lab assignments are and where the written test is, etc. That's all I have. So I hope everybody have a good day. See ya.